The isometric midthigh pull is a multi-joint test designed to measure an athlete's force-producing capabilities. As the name indicates, it's isometric. The bar is fixed in place and doesn't move. The test itself is relatively simple and quick to perform. Once in a position that mimics the second pull of the clean, the athlete pulls as hard as possible on a fixed bar for 4 to 5 seconds. When performed on a force plate, measurements such as peak force and rate of force development can be recorded. Specifically, isometric midthigh pull peak force has been associated with dynamic strength, including 1 rep max lifts like the snatch, clean, squat, bench press and deadlift. It has also been associated with sport performance outcomes, such as throwing distance, track cycling performance, sprint speed, change of direction, and jump height. The isometric midthigh pull is also often used to monitor training adaptations and help inform future training. But here's the issue. Since the isometric midthigh pull was first introduced into the literature by Haff and colleagues back in the 90s, studies have not always been consistent. We see differences in joint angles, sampling frequencies, and even how the onset of the pull is identified. These inconsistencies make it difficult to compare results across studies. That's why Paul Comfort and colleagues published their article on standardization and methodological considerations for the isometric midthigh pull. This is Talking Sports Science with a summary of their recommendations. First of all, before testing, the bar must be set at the correct height to match the second pull position of the clean. It's recommended to adjust the bar until the knees are bent between 125 and 145 degrees, and the hips are between 140 and 150 degrees. In this position, the torso is upright, shoulders are pulled back and down, knees are slightly flexed, creating some dorsiflexion at the ankle. Knees are positioned underneath and slightly in front of the bar. Feet are hip width apart, under the bar, and the thighs should be in contact with the bar, close to the hip crease, depending on limb length. A clean grip with hands strapped and taped to the bar is recommended. To keep results consistent, it is important to record the joint angles, foot stance, and grip width so they can be replicated in every testing session. When measuring joint angles, no pretension should be applied to the bar, but any slack, like bent elbows or shrugged shoulders, should be removed, otherwise the angles will shift once the athlete pulls maximally. Before testing, athletes should complete a standardized warm-up, which involves 3 stages. First, a general warm-up, using simple bodyweight movements, like squats and lunges. Next, a dynamic warm-up, consisting of performing low-load and moderate-load midthigh pulls. Finally, a specific warm-up, consisting of 3 3-second isometric midthigh pull trials, each separated by 60 seconds rest, performed at 50, 75, and 90% of perceived maximum effort. During this time, the athlete should be secured to the bar using lifting straps and tape to make sure grip strength is not a limiting factor. A short familiarization session, ideally 48 hours before testing, is recommended. This can consist of 3 3-second pulls, again at 50, 75 and 90% of effort, to help athletes get comfortable with the setup and the effort needed to perform maximally. Now moving on to what instructions to give. As clear and consistent instructions are essential. Tell the athlete push their feet into the ground as hard and as fast as possible. It is important that the athlete knows the focus is to drive their feet directly into the force platform and not pull the bar with their arms or rise up onto their toes. Provide a countdown of 3, 2, 1, pull. This gives the athlete sufficient warning to be ready to give a maximum effort and provides at least 1 second of quiet standing to enable the identification of the onset of the pull. Strong verbal encouragement from the coach or tester is needed to ensure the athlete gives maximum effort. Moving on to what is considered an acceptable trial. At least 2 trials should be collected, but only if they are both error-free. So what does an acceptable trial look like? First, there should be at least 1 second of quiet standing. This gives us a stable baseline force that represents the athlete's body mass. Once the pull is complete, the final force should be comparable to that baseline. This confirms that minimal pre-tension was applied. Now let's look at an invalid trial. The trial on the right is not acceptable. There is an unstable period of quiet standing, a visible counter movement before the pull. Peak force has occurred at the end of the trial. It should occur more towards the beginning of the pull, as shown in the trial on the left. Also, the force trace drops to zero immediately after the pull, meaning the athlete stepped off the force plate too soon, which we don't want to see. When comparing trials, peak force values should be within 250 newtons of each other. If the difference is greater than that, repeat the test after 1 to 2 minutes of rest until results are consistent. Throughout the pull, posture should remain constant. Viewing the athlete from the side helps to confirm joint angles stay the same. Baseline force should be within 50 newtons of body mass, and the force at the end of the pull should also be comparable to baseline, again confirming no excessive pre-tension was applied. By checking the force time curves visually, we can quickly determine whether a trial is acceptable. Stable baselines, no counter movement, and consistent peak force between trials are all key for reliable isometric mid-thigh pull data. And lastly, data analysis and reporting. When collecting isometric mid-thigh pull data, the sampling frequency is important. A minimum of 500 Hz is acceptable, but ideally use 1000 Hz or higher, especially if you want early force time measures like force at 50 or 100 milliseconds, and if possible, use raw unfiltered data to help ensure a more accurate measurement of rate of force development. To accurately identify the onset of the pull, automated methods are often used. The recommended threshold is 5 standard deviations above baseline force, i.e. body weight. That's why it's important to make sure the weighing period baseline is stable. When using the isometric mid-thigh pull as a sport performance diagnostic tool, it is also recommended to report time-specific rate of force development values, for example at 50, 100, 150, 200 and 250 milliseconds. These measures can be selected specific to the durations relevant to the specific sporting tasks. In contrast, maximal strength capabilities can be inferred from peak force. So when reporting isometric mid-thigh pull results, it's essential to report the hip and knee angles used, whether body weight was included in the force values, the sampling frequency, the method and threshold used for identifying pull onset, and any filtering, smoothing or scaling methods applied. This level of detail ensures results can be accurately compared across the athlete's sessions and studies. And that concludes this summary of Paul Comfort and colleagues' article on the standardization and methodological considerations for the isometric mid-thigh pull. As always, go and check out the full article. The link is in the description. Thanks for watching, folks. See you next time.